Hi, I'm Chris from Suprock Technologies, and I'm here today to talk about an installation of our Turbo Commander product. And what we're going to do is we're going to put a Turbo Commander on a custom VTG in a Subaru WRX. And this engine is configured as a 2.5 liter. It's got a TD05 turbocharger with an experimental VTG in it. I know there's going to be a lot of questions about the actual VTG in the Subaru, but we'll try and address that later. It's in development. So what we've got with us today is a Turbo Commander unit, and we're going to set this up to operate a VTG in this vehicle using a stepper motor. And we've got a stepper motor actuator already installed on this turbo. So this would be similar to a custom setup where you would use a stepper motor to actuate. We've also got pressure inputs for exhaust pressure and charge pressure, in addition to an exhaust temperature thermocouple that we'll use as a safety limit. So all of these sensors going into the Turbo Commander are going to be set up to run this turbo and put it into conditions that are optimal for the amount of flow, temperatures, and pressures in this engine. Okay, we're going to install the Turbo Commander in this vehicle now, and taking a look at the inputs on the Turbo Commander, we've got USB, we've got a large connector here with power, in addition to some other inputs that we can discuss later. There are charge and exhaust pressures, and then we've got thermocouples. In this embodiment, we're not going to put a speed sensor on the turbo, but that's something that we'll also take a video of later. We're using a stepper motor to actuate, so our M12 cable is connected to our stepper motor. We're going to install that as well. The stepper motor is already mounted and the cable's already routed for that as well. So what we're looking at here, we've got manifold pressure coming off of the manifold, and that's what's being fed to the engine. So as far as charge pressure is concerned, using manifold pressure is preferable because that's what's actually going into the heads of the engine. Exhaust pressure is also coming from a hose here, and one of the notes on exhaust pressure is decoupling the exhaust pressure hose thermally from the manifold. So if you weld a bung, or if you have a bung, if you're lucky enough, then you want to use a compression fitting or a piece of stainless tube to thermally relieve the hose connection so that you don't end up getting hose burning. Another note about exhaust is also to have it gravitationally lower. So basically you want the condensation to flow back into the manifold when the car cools down and not rest against the Turbo Commander. Even though these are sealed to liquid ingress, that will carry soot and have buildup over time if it doesn't drain out. Okay, so let's go ahead and connect this. I've got the exhaust hose already in the vehicle, as well as the charge pressure hose. So those just simply connect to the barbed fittings. The stepper motor, likewise, is an M12 connector. That's an industrial connector. We prefer to use these for steppers because they're robust. They have a lot of resistance to kinking or bending, and also the connectors are locking, and they're pretty nice. Our additional input is an exhaust temperature thermocouple, so we're going to put that into the port that says EGT. It's a standard Type K thermocouple, and that plugs right into that port. Finally, we've got our large terminal block connector with power connected. And the other inputs on this terminal block have to do with things like a CAN actuator, which would be for a whole set, for instance, a 351 VE turbo that has CAN interface for an actuator, and also for solenoid, and then there's some auxiliary inputs for things like voltage. So I'm going to use the power connection on this right now for this installation. We'll go over these other connections in subsequent videos. So there's power from a fused 12-volt source going into ground and V in. Finally, the USB connector goes into the Turbo Commander, and this is for doing things like high data rate logging and setup from your PC. This also has Bluetooth, and it will connect to an Android device so that we can use the Turbo Commander app to monitor while we're driving and display parameters live. So that's the setup basically for what we're going to do, and what we've chosen for control on this is a pressure-based control. So we're going to look at the manifold pressure and then base our turbo set points off of that pressure, as well as safety limits based on the EGT and the exhaust pressure. Using our USB connection on the Turbo Commander and the configuration software for PC, we're going to set up our limits and then also set up the parameters that control the stepper motor. Using the overrides in the Turbo Commander software, we are able to test our limit positions to ensure that we are actuating the VTG mechanism between its open and closed position properly. So as you can see right here, we are using the overrides to test whether or not the limits on this VTG mechanism are being exceeded, and we've set this up so that it has the correct number of steps, so it looks like it's going between open and shut properly. So this is with the control loop disabled, and if we enable the control loop, it will stay in the closed position because it's not reading any boost and there are no error conditions being read by the controller. Okay, so now we've got the app paired to the Turbo Commander, and I've got the graphical screen up right now, which shows the stepper motor position, pressures, and some other parameters. We don't have shaft speed hooked up right now, but it's still on there. And there's a list format as well that we can look at as we're driving around. If you have a mount for your tablet or your phone, you can view it on that. It's a lot easier to mount this up so that you don't have to hold it while you drive. Let's go for a test drive and make sure this works, and then we'll go from there.